Hello and welcome to episode 7 of the Go series. We are pushing basically near the end, considering that I've already created publicly available builds that I will talk about later. And I'll talk about this later at the end, but I think the Go series is coming close to an end. So let's start. So number 1, the code is uploaded, so it's publicly available, and anybody that wants to access, modify, or even privatize the source code is available to do so. I'm not sure what you're able to sell out of my project, but I don't really care if you do. And if there's any improvements that you would like to make, feel free to fork it and make a issue or make a pull request. And then we could try to merge those two branches together. The code is just available for anybody to look at. I wouldn't call it the most ideal code. It is messy, and it honestly is only understood by me. But as for the principle of open source development, I wanted to make sure that my project is open source and freely available for anybody that wants to take a look at it. Alright, so here are the two commands that I worked on, and I'll talk about the other two right after. So first one is ddnsu clean. So what this does is it will delete all the records managed by ddnsu on the remote record. So basically it will go through and find all the records that start with the D prefix that we detailed, and it will delete it. And then in order to, say, if you had originally a record on the remote and then you remove that from your configuration, all you would have to do is run the clean command, and then you would run the start command, and it will re-instantiate your new configuration. ddnsu install. So how this works is it will create a user-level systemd service that will download a ddnsu binary and will allow it to run in the background. So as you can see in the GIF here, so we install it, and then what it will do is it will download a shell script, and then from that shell script it will download a binary, and we will take a look at what that shell script is, and then it will move that into a systemd service, and that systemd service is able to run in the background, not interrupting the terminal window, so it's not occupying it, as well as it's able to run on reboots, on system failures, and so on and so forth. So ddnsu config will not be worked on, because this is how I feel about this project right now. And the functionality of ddnsu config will basically be that of ddnsu test. It really is the exact same command. ddnsu test obviously just looks at the configuration file and gives you an example of what it will look like. So the config and the test are practically the exact same, and you can already interact with the configuration file through either manually editing it or using the ddnsu record command. So here are some snippets of code. So here's the systemd service. So you can see it's just an example.service. All services for systemd will be denoted with the .service, and here we describe the description of what that service will be. And then after, so this is saying what it's dependent on. So after network.target means that the systemd, so it's the systemd in Linux, is responsible for the entire system and all of its daemons, basically, that's what we call it. So for example, systemd is responsible for your networking, your screen state, your C states, right? All these different processes of your computer are dependent on systemd, and a lot of your services, right? For example, say Docker, that's just a systemd service. So here we're saying that it's dependent on network.target, which means that the network service has to be already up before we start this one. This is obviously evident because ddnsu cannot operate without a network. Because if there was no network, obviously it wouldn't be able to make any requests to Cloudflare's API servers, and as a result, it won't be able to do anything. Type simple is just saying, again, this is kind of a boilerplate that I generated, but the type simple is just saying that this is a really simple service. We don't have a lot, and the standard output journal means that, say, if there were any errors, you would be able to view what went wrong with the journalctl command. And exec start, that's where the main process is occurring, which I'll talk about. So basically what happens is a script is, when you run ddnsu install, we'll put a script at this location at the .config.ddnsu and the run.sh, and we will take a look at that script after. But what will happen is that this systemd service, whenever it gets started, it will just execute this script here, and then once it by, this is just saying who can run it. So this is a user because it will be in the .config/systemd/user, because if it was at the etc systemd user, etc., then we have to deal with permissions and who can read, who can write, who can execute, and that's just kind of a pain in the ass. So I wanted to make it simple. So here is showing the retrieval of the @user. So you can see right here @user, because obviously the username for each system will be different. Like for mine, it's just Lee, which goes to the character on my YouTube channel. And you can see here, so what happens is we use the user from the os/user package, which is just part of the standard, one of Go's standard packages. And what we do is we check what the current user is, and it'll see whether or not we had an error retrieving that. Because if there was an error, then obviously we don't know what that user is. But most of the time it will be fine. And then we just take the example service embed, which I'll talk about actually later, and we replace the @user instance with the username of that user, and -1 saying that we will replace all instances of it. So you could change this number to say 1, 2, or 3, which is saying, like, if it was 1, we would just change the first instance to the first 2 instances, etc., etc. But because in our system D service there's only one @user, we could just say -1, because we won't, there's not another @user that it's going to replace and somehow fuck it up. So here's creating the systemd service in the bash script. So I modified the code from last time with the utils that determine file existence and create if does not exist, because, and people said it's simple, but to me it's just kind of a pain in the ass to make files compared to what I'm used to. But so I wanted to create a generic function to do that. So basically what it does is it will look in a directory, and it will look at the file, and if it does not detect this file or this directory, it will take this third argument here and put it in that file. And you can see here that we use this one right here for the systemd service, which we convert that service script string into a byte array, because to write into a file we use byte arrays. And then active script here is the exact same. So that's the .sh that I showed, and you can see here it just takes it goes to the same .config folder, and it will open up run.sh, and it will see or I'll put the contents of this into it. And then this is actually kind of important, this os.changemod. So changemod is a Linux command, as well as it's pretty prevalent within any file IO library, which stands for change mode. And so change mode allows you to change how it is. So like, for example, you have read, write, and execute mode. So those are the three principal modes of any file. And so here we can see .077. So this is saying all users can read, write, and execute. So the user that created it, all groups can do it, and as well as the root user, or like system user. So 077 is going to be your most powerful, and I would be cautious using for other stuff, but because this is just for running the DNSU binary, I don't really care, and I don't think it can be abused. And yeah, and then this is showing that right here it's done. So here's the bash script. So first we have the shebang. So the shebang details what interpreter we need to use. And for ours, it's bash. Most Linux systems will be bash, but you can actually change it. You could do /bin/python for all, whoever cares, and it'll just use what's under the shebang to interpret what's inside. But bash is the most common. So what it will first do is it will check whether or not a DNSU binary already exists. So this is denoting whether or not so this is checking if it does exist, but we want it when it doesn't exist to download it. So we use the negate, the not basically. So we'll just basically do the inverse or the opposite of this. So for example, if it wasn't detected, then this would take false, but we want it to be true to enter in this if loop. So or this if block. So we'll invert it. And then here is going to get the architecture of the system. Your most common will be x64, but there are some systems that are still 32-bit or /i386 or ARM, the newest architecture. So we'll detect it by first getting the architecture by using the uname-i, and then we'll compare it to these strings. So this is x86-64, so this will be 64-bit, this is 32-bit, and this is your ARM bit. And then what we'll do is we'll alter the second variable, A is short for architecture, because I don't want to modify what I'm comparing it to x64, x32, or ARM64. And if there's, if this doesn't happen, then who knows what you have, right? This is like just a common Linux thing. So this is going to say that it couldn't find the DNSU binary, obviously, from here, and it will download it from the latest GitHub release. So what happens is we use curl, which will request. It's basically a request. It's like wget, which you can see here, but wget's more for downloading. This is more for like APIs, and we'll just contact the GitHub API and find the latest release, and it will basically search through. So this is kind of taken from Stack Overflow. I don't know exactly each line, but I was able to modify it for my words or for my uses, and you can see here it will search for the DDNSU architecture binary in that release, and if it does, it will basically filter it out and then download it with the wget -o, big capital O, and this is saying where it will be put out, and we just show a progress bar Here, and this hyphen just saying that we're taking the input of all this shit. So yeah, right here is the modify, and then we take in the A, which is shown through the $ in parentheses. This is called substitution. So just take whatever is in there and then put it in there. And then we want to make sure that it's executable, so we'll change the mode. So basically this is equivalent to, or very similar to 077. So you can use numbers, or you can use letters. So for chmod plus X, this is just saying it's executable, and it will be make sure that the binary is executable. And so basically, if it already exists, so the systemd service will run this every single time that the service starts, but we don't need to download it every time if it already exists, right? So we have here XX, so this is just going to say that we're going to execute the start, and if it already exists, then this whole if statement isn't going to occur, and it will just execute it. So what are embeddings? So this is a video that I watched. This is what actually got me, or like taught me what embeds were, and actually got it on my radar. So I will link it in the description because it's a much better video than this one, because I'll just do a brief overview as to what it is. But basically, embeddings are in a way to integrate files or file-like systems into the binary itself, so it doesn't have to be packaged alongside a binary. So like for example, I really like the example configuration, or not configuration, but the example systemd script or the example shell script. In those two cases, if I wanted to have it modified, I would have to ship the binary with those files alongside it, or like have it in the program where it will download it from some remote servers. With embeddings, it can act just like a file. However, when I build it, it's going to be packaged into the binary itself, and it won't require that I package the file with it. So here's how you can declare an embedding. So you can see we import the embed, and then we have to use this. This is kind of the alias of the embed import, and the underscore just saying that we aren't going to directly reference it, because for embeds, it's all going to be declared in comments. So here we can see that we do the go : embed. So this is denoting that we're going to use this embedding, and then example.tmo. So what comes after is the file that you're trying to embed, and then right under it, you're going to put your variable that you're going to, basically the content of that file will be put into. And your comment beta types, it can be string, it can be a mock file system, which is that video goes more deep into it, because I did not use a mock file system for mine, but my most common was byte array. And you can see here, so for this, it has to be on the same level as the file that you're embedding it in. So the embed.go, basically the example.service and the example.sh are on the same level of hierarchy in the file system, and you can't use relative imports because when you're building it, it doesn't necessarily know what's relative to what. It's not like JavaScript or TypeScript where it's relative to the file itself. It's relative to the execution context. That's the problem. That's why you can't use relative. So that's why you have to have these exact, because it's going to be able to denote that it's on the same level of context, and it can just embed it. So here's how I avoided circular dependencies, because the install command is under our commands folder here, right? So here you can see this workflow. So in the main.go file, we have that commands/install.go, which is what's run when you run ddnsu install.go, and there triggers this function install command. However, this command needs to access these embeddings in the embed.go, which have the example shell embed and the example service embed. However, if we try to do that, can see that we go in a circle, right? We go circle, 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 and what will happen is basically stack will overflow and the program will crash. So in order to not have that happen, we had to engineer, or I had to engineer a different workflow. So because this is showing that the embed and the main are on the same level here, so with the install.go is also when we start the main program, because obviously this imports, to start the program, we use /ddnsu, which executes the main function here. And then, oops, only there is where it embeds, or sorry, where it requires the, where it installs basically the command. And we can see on the func.main, what we do is we're gonna, because the function of the main file and the embed file are on the exact same execution context, what happens is in that func main, basically it will copy it to a subdomain, right? There's variables which can be imported from other files, even within different execution contexts, or different file structure hierarchy in a different part of the hierarchy. We just copy it to basically the exact same, it's basically a clone of the exact same variable here. So just copy there, and then now the install command no longer accesses it from the embed.go file, but it uses from the global/vars.go file. And you can see here, you can actually follow it with the arrows. shit, I keep doing that. But the arrows just end up here. It doesn't go in a circle. So that basically won't cause the project to crash. So here's how I use the embeds, for example. This was already there, but basically these embeds, and then this is the install script, and you can see here that we just use the service script and we just kind of copy what's in that embed. So this is the most annoying part of the project, I feel like, was GitHub workflows. This is literally what it felt. This is what GitHub workflows feel like. So here's the workflow that ended up working. And so what happens is we define a build.yaml file in the .github/workflows in the project. And you can see that this is going to say that this is the name of the action that we're doing, basically, or workflow. And then it's going to say this is kind of what signals it to start running, and that's whenever we push files to it on the master or main branch. And then here's the job. So this is an actual building process. So it's going to run build, and it's going to run on this Ubuntu server, and it's going to first get Go. So this is our Go version here, and here are our steps. So these are the steps of what's going to happen in that Go workflow. So first we're going to check out, which basically is saying that we're going to copy all the code into whatever this VM is, this container here, and then we also will install Go from this version here by using the setup Go, and then we'll install the dependencies of the project, because without the dependencies then we can't build it, and that's the Go mod download, and then we will run the build command. So that's just make, so we just use makefile, and then we'll upload it. This last part here, upload artifacts as a release, that's the most pain in the ass one, because there's so many different ways to upload shit, but this is the one that ultimately ended up working, and I'll show you how many times it failed. And then here we can see the make file. So in the main, basically we define in the make file, this is just what's going to run, and we describe here the operating system in which it's going to operate in, and then this is going to say what architecture we want to make it, because obviously we want to build 3 different architectures for like the 3 different possible architectures out there, or most common ones. And we're going to run the build command, and we're going to output it with that suffix, and we're going to make sure that we build it with all that Go files, and it's just going to end up in that build/ddnisu or build folder, and that's what ultimately gets uploaded here with the files build. So here's the evidence of my suffering. This is a lot of fucking annoying shit right here. Fixed, I hope, changed, like all of this doesn't work, and it was just a pain in the ass to do. So, okay, this is what I referenced to at the start. What is going to be the future of this series? So, in terms of what I think is left, is there's probably going to be about 1 or 2 more videos, at least for this DDNSU, because I feel that it's nearly complete, and I don't have any big changes I want to make to it. So I think one of the videos will be a comparison to what it used to be, right, written in TypeScript, and kind of seeing performance, size, and like almost even a sense methodology in doing so. And the last video, who knows? But I don't think the Go series is dead, at least not completely. I want to use Go for other projects, and I definitely will record those projects and record how I'll use Go in those instances. Not to mention that there's a lot I want to learn. So there's like Rust I want to learn, for example, and I want to learn about artificial intelligence and like math, even those things. So in that case, these series aren't over, and it's not like my YouTube channel is over either. It's still going to be programming, it's still going to be AI and that kind of stuff. So in terms of what Go and my skills that I've learned in Go over this, this past month in building this series, is that I believe that I will start a Go series number 2. A second series, and it's going to deal with artificial intelligence. I hinted at this in one of my previous videos, but I won't say exactly still. It will happen when I release it, or when I start it. And I also work on other projects that I will talk about. My content is really focused on like Theo's style, Theo T3 style of just talking, because I'm a yapper, and I love talking about programming and my hobbies and my skills. So yeah, this is the future of this series, so this is probably going to mark one of the last developmental episodes, meaning that no more Go programming is going to happen after, at least for DDNSU, and the remaining video or 2 are probably just going to be comparisons and kind of talking about and reflecting upon what I learned. Other than that, I look forward to the next Go series with you all. Alright, take care.